Hello, Penn State Ag Springboard panel and audience. Together, we are collectively the GreenTowers Project Group, and we form a highly sustainable aquaponic greenhouse design and microfarming business initiative. Our business model is designed to deliver hyper-localized, small-footprint, organic agricultural food production into the hands of everyday urban restaurants, municipalities, and private citizens. The business model aims to generate vertical aquaponic greenhouses produced from recycled and converted standard shipping containers, and then affordably retail these sustainable agricultural production units to a widely democratized urban and suburban customer base.
So whenever I tell someone like I'm working on aquaponics, they instantly get this like glazed over stare, and you immediately have to explain, oh, aquaponics is when you take the water from fish that's dirty with like poop, and you pump it through plant beds, and you make the poop be the organic fertilizer for the plants. And then the next thing people say is they're like, that's awesome, that's a great idea. Why aren't more people like doing that? So aquaponics is the mutually additive blending of hydroponics, which is soilless plant growth, and farming fish. So our system takes advantage of that to make a grow system that is low inputs. So it has a little bit of water that needs to be added to balance the system, and then food goes in, and then it outputs both fish and vegetables.
So why choose shipping containers, also known as intermodal steel building units? For example, it's structurally robust and overabundantly available. They're piled high across ports throughout the world. They're easy to ship by ship, train, or truck. And they also come weatherproof to withstand gale force weather on the open seas. Shipping container architecture is already very well established and a sustainably minded practice in architecture. And there are many reference books, such as the one by Paul Sowers, on how to customize and fabricate these ISBU units in any type of construction project. The program that I used to model these containers was Rhinoceros 4.0, and this allowed us to model the container, modify it, and see how it would work structurally and how different materials would look. We could check out different heights of the grow beds to see how much we could change the structure and how we could modify it to the most practical means possible, and allow us to see how this model will look in front of stores, which will in turn provide the clients with a great idea of what they can expect and how people will view this project from the street and how it will bring them revenue.
With rising global population, food security has become a high priority. Locavore and organics food movements have been continually upswinging in the United States. Food consumer markets are ready for serious, scalable, urbanized agricultural production. GreenTowers will deliver upon these urbanized locavore market demands, bringing organic food accessibility to limitless, small-footage urban spaces.
Dr. Dixon DePomier's brainchild concept of vertical farming is in many ways the inspiration for a lot of our own concept ideas. But vertical farming never quite gains the momentum that many agricultural entrepreneurship optimists had really hoped for. And it was really, I held back primarily, I think, by the astronomical costs of starting up a skyscraper farm, and also the concerns about light penetration into these large diameter buildings that most vertical farms are, because they're designed to look like skyscrapers. And our considerably smaller idea with GreenTowers will experience neither of these startup hindrances. Its diameter is small enough that light penetration will not be an issue at all, and the startup cost for somebody to purchase one of these to go into urban farming is extremely minimal.
The manufacturing renovation process will transform old and arguably wasted shipping containers, or ISBUs, by converting them into vertical greenhouses. This will be done by stripping the containers of 3/4 of their lengthwise corrugated sheet metal siding, and then retrofitting these sides with 3 walls of greenhouse acrylic polycarbonate transparent window paneling. One of the greenhouse's vertical walls will remain opaque, as it is made to be the shipping container's horizontally reinforced floor. By keeping the single opaque sidewall, We will preserve the shipping container's ability to be transported, allowing the green tower to have minimal assembly upon delivery at essentially any location. The single opaque wall will be positioned on an individual installation basis in order to maximize light delivery at any given location. The opaque side could also be positioned against the exterior sidewall of an existing building.
So GreenTowers floors of plant growth will essentially be placed at 8-foot intervals with 2 concentric U-shaped rings of grow beds on each floor. So this means that in the 20-foot container model, we would have 4 grow beds, and in the 40-foot container model, which is twice as tall, there would be a total of 8 U-shaped grow beds. Thinking about this economically for harvesting sequentially, we could grow lettuce maturing which takes 4 weeks, and we could harvest 1 grow bed each week, and then have an entire grow bed's worth of lettuce harvested each week for that business or micro farming entity. Water will be circulated through a design-integrated deep water culture continuous flow aquaponics system. What this basically means is that the fish effluents that are excreted are taken directly out of the aquaculture tank and first sent through a vortex filter that takes out all the solid particulate matter, which is actually really nutrient-rich and great for gardening. The filtrates will then pass through a secondary solids filter and through a biological filter. And the biological filter is basically just a surface area for these naturally occurring bacteria to colonize that will convert the ammonia excreted by the fish into nitrites and then into nitrates, which are used by the plants in the grow bed for the aquaponics system.
A regular shipping container is meant to be transported on a horizontal level. We need it to be in a vertical orientation. So how do you do this? What our theory is we take a triaxle dump truck, like you'd see on the road today, and then modify it in a few different ways. Basically put hydraulics to change the center of balance on it, and then also attach a modified industrial winch, so that way the truck actually turns the shipping container upright and then drops it and places it in the orientation it needs to be.
So actually, underneath your feet when you walk through the greenhouse entrance of GreenTowers will be the fish tanks, and the fish, you'll actually be able to see them visibly swimming beneath your feet through like a sort of metal grating that will be like a polished stainless steel or something aesthetic like that. So as soon as you walk in, you'll see the fish underneath you, and that'll be a part of the experience. Also housed underneath that kind of trapdoor platform will be the various stages of filters, mechanical filters and biological filters for solid removal. And so all of the sort of plumbing and sump tanks will be housed underneath your feet, and you'll be able to see the fish swimming beneath you. So the GreenTowers design calls for 2 pumps, which can be regulated completely independently and conjoined together. Actually, both pumps move out of the sump tank in the middle. And so the first pump controls the aquaculture tank, which has to pump at a gallon per hour rate equal to the number of gallons in the aquaculture tank. For our 500 to 600 gallon tank that we will install, this will pump at 500 to 600 gallons per hour. And then the second pump will independently operate the flow rate through the grow bed. It can pump continuously, and we can also adjust the flow through the beds for different crops, for experimenting with different sorts of crops or with energy savings. And so the 2 pumps make the system a lot more modular in terms of control. Floors of concentric plant growth within the green tower will be accessible by a central pulley platform that moves between the U-shaped grow beds, as well as a backup access ladder. And this pulley platform will be designed for efficient vegetable harvesting so that you can make a sizable harvest while on the platform and minimize the need to go back up and down the tower throughout the day. In terms of temperature relief systems for the GreenTowers system, summertime temperature relief will be very easy to take care of. Since the Green Tower already has water being pumped through it constantly, it'll be really easy to employ a sort of passive cooling pad where you just run a fan next to the cooling pad to just just a simple evaporative cooling process. And so we'll be able to essentially hook one of those up anywhere in the tower because there's water going through it at all points. In terms of wintertime temperature regulations, obviously the polycarbonate greenhouse siding that we have chosen is pretty adequate for most commercial operations, even into the winter months with the 8 mm two-walled polycarbonate. But we're also really hoping to soon be able to prototype a nighttime curtain design that we have. So this curtain would be deployed at night, and what it would do is add insulation to the greenhouse as well as block light pollution that would probably take place in most city areas. In addition to those two main features, I think that a sort of nighttime curtain, which we're hoping to be able to build from the recycled corrugated sheet metal siding that we removed from the container, this metal curtain would also add a sort of nighttime security feature that we think would really be nice to have on the Green Tower.
So some theoretical revenue streams include production sales, which would be upfront, some upgrades, checkups and maintenance, and also a network for aquaponic microfarm supply management, and it would be integrated ordering and delivering customer accounts.
So there's a pretty good variety of customer bases that GreenTowers could conceivably market to, and probably the biggest breakout market of those is the restaurant business. And I mean, if a restaurant can put a Green Tower in one parking space's area of its parking lot and produce all of the arugula that it needs, it doesn't have to order arugula twice a week shipped by a Cisco truck from Nevada. And it will end up, in the long run, definitely saving these kind of restaurants who want to sustainably produce their own products on site a lot of money. Another sort of maybe along similar lines market is if there were vegetable producers within the city, and we'll call them urban farmers, who don't actually own any land, but know 5 or 10 people in the city personally or well enough that they can place a microfarm on each of their property or pay a small loan to have just lease that small amount of property, then I can conceivably grow vegetables and source them and sell them directly to restaurants or fresh markets within the city and not actually own any farmland. So micro farming is definitely, within the city limits, is definitely another potential market that we're really excited about.
This product could be used in urban food deserts, school systems that want to branch out into healthier lunches. So one main source of a revenue stream could be from municipality and government support.
Looking at the Green Tower's business model, cost analyses, and financial projections has actually been a very exciting time for our team because we've realized that this financial model really can generate substantial profits. Sizing up our own variable production costs reveals to us just how competitive we're going to be in the aquaponics market. Producing a larger grow bed space with an integrated vertical greenhouse component for just what one of these, the greenhouse or the grow bed, might cost from one of our aquaponic competitors, such as Bioponica. It's important to note when looking at these financial projections that the calculations are based on the assumption that 50% of our sales will be from 20-foot units and 50% will be from 40-foot units. The two models have distinct cost estimates that you can see, with the 40-foot shipping containers retailing from used shipping container resellers for about $1,000 more than their 20-foot counterparts, and with the remodeling of the interior of a 40-foot model definitely costing a little bit more, although not quite twice as much as the 20-foot model. Averaging the prices together gives us the working revenue value of $87,500. If we take a look now at the 3-year financial pro forma, we can see how a first-year gradual ramp up in sales might look on a quarterly financial statement. In month 1, we produce and sell only 10 Green Towers units, operating at about 33% of our year 1 target production capacity. We can then move out further and see that in quarter 2, we're operating at 50% of the target output, producing 15 units in a month or 45 units in the quarter. And by quarter 4, we have theoretically reached our year 1 target output of approximately 1 Green Tower unit produced each day, for a total of 90 units produced and sold in the 4th quarter. The year 2 projection holds steady this production rate of 90 units per quarter, for a total of 360 in year 2, and the year 3 projection shows how profit would look operating at about double the output capacity. The Green Tower's financial return curve is very encouraging, with an initial fixed startup cost estimating $1.1 million for investment in machining, delivery, infrastructural expenses, as well as the added startup costs of employee training and website costs, and even taking into account the relatively gradual increase in sales over the first year, GreenTowers still breaks even midway into its second year of sales and operations, which is really exciting, especially given $1.1 million in upfront costs. The visible increase in the slope that you can see starting in quarter 9 shows how profit earnings would increase if sales were doubled to 720 units total for year 3. While the startup investment costs are definitely a rough working figure, the overall profit projections are really encouraging, especially given GreenTowers' modest pricings, we feel, in $7,500 and $10,000 for the 20 and 40 foot models respectively. For our team, this financial report tells us that there's real substantial value in prototyping this design as soon as is financially feasible for us, and it confirms for us just how well a micro farm production model might work financially, and it encourages us to want to push this business proposal to the next level. Marketing into a somewhat emergent industry means that GreenTowers as a company really needs some way to more actively facilitate customer creation. Our solution to this problem will be to create our own online location-based collaborative social network. This way, as a potential customer, I can see urban farming discussion threads going on in just the Philadelphia area, or I can filter my search even further down and see discussions taking place just in the University City area to see who right around me is also interested in micro farming. With this social network and online knowledge base in place, someone just potentially interested in GreenTowers could conceivably connect, meet up with, and then decide to go into a micro-farming venture with someone who they potentially just met on our website. Potential customers might be able to plan community GreenTowers projects together and build their own interests by asking questions, leading to more community purchasing and social aquaponic gardening experiences. With this kind of platform, all necessary split payment signing plans, ownerships, and liabilities for neighbors or property owners who will be co-purchasing a green tower together will be completely streamlined, making the delivery process of Walnut Street and 34th's first community greenhouse into a very simple and exciting process. And we hope that this sort of customer creation could range from micro-farming producers, as I just said, to possibly co-ops, or even aquaponic urban community gardens, and that these networks would facilitate ongoing business relationships that we could build off of into the future. The GreenTowers team is really remarkably well networked with computer engineers and programmers already through our friends at the Downtown New Leaf Initiative and the Makespace, and we really all think that this sort of collaborative web platform can assist us in accelerating the growth of our own customer markets. There are so many people out there who are already extremely interested in urban farming, and we think that this web design will really be the best way to network these people around our own business and product, and thereby facilitate the growth of our own customer base, even in an emergent industry like urban agriculture. What really makes GreenTowers unique among other aquaponics ventures and other sustainable farming ventures is that we're taking a shipping container of products that is arguably wasted every day sitting in ports around the world and turning that into a sustainable unit of production. And we're also taking aquaponics and turning it vertically, which is something fresh that I don't think has really been done before.
Our goal is to deliver healthy and sustainable food production to you, our neighbors, regardless of whether you are at a restaurant, a landowner, co-op, coalition, or community garden. With so many small footprint spaces to occupy, GreenTowers is a clear choice for sustainable development.